Ever open up a data set and just feel lost? Like it's just too messy to even know where to start? Well, you are definitely not alone. Over the next few minutes, we're going to talk about how to tame that data and turn it into something clean, clear, and ready to tell you its secrets.
Does this look familiar? You've got one variable, say age, but it has dozens and dozens of different categories. How are you supposed to find any meaningful patterns in that? It's a super common problem, but trust me, the fix is easier than you think.
And that's really all we're doing here. It's called data cleaning or data transformation. We're not changing the results, not at all. We're just tidying up the raw materials so that the real stories can actually pop out. Think of it like organizing your garage before you start a big project. You got to be able to find your tools, right?
So we have two main moves in our playbook to get this done. The first is recoding, which is basically just reassigning values for clarity. Maybe you want to change a 1 to a 0, for example. Then there's collapsing. This is our go-to when we have way too many categories. So instead of having every single age from 18 to 99, we can collapse them into a few simple groups, like 18 to 34, 35 to 64, and 65 plus. Much easier to work with.
Okay, but hang on. Before we dive into the software and start clicking around, I need you to listen up. There is one single, unbreakable rule that is more important than anything else we're going to cover. Getting this wrong can wreck your data, but getting it right is incredibly simple. And here it is. This is the golden rule. You ready? Never, ever recode into the same variable. It might look like the easy option, a quick shortcut, but it's a trap that can permanently, and I mean permanently, mess up your data set. Here's why that is.
When you recode into the same variable, you are literally overwriting your original data. It's gone. Poof. There is no undo button, no going back. If you make one tiny mistake, that original, precious data is lost for good. That's why we always recode into a different variable. This way, you create a brand new, safe copy to play with, and your original data stays perfectly untouched and safe. All right, now that we've got that critical warning out of the way, let's get into the good stuff, the solution. We've got a super simple 4-step mission plan that will help you do this safely and accurately every single time.
Our roadmap is dead simple. First, we plan our changes with something called a recoding tree. Then we execute that plan in the software, the safe way. After that, and this is crucial, we check our work to make sure it's perfect. And finally, we finalize it all by labeling our new categories so we know what's what. Plan, execute, check, finalize. Let's do it.
Step 1 is all about the plan. Seriously, before you even open your data file, you need a blueprint. We call it a recoding tree, but really it's just a simple map that lays out exactly what you're about to do.
And here's what one looks like. See? It's not complicated. You just map your old values, in this case our age ranges, to the new codes you want to use. Then you decide on a clear label for each new code. This little table is going to be your best friend. It's your guide for the whole process.
Okay, time to execute. Step 2, we're going to stick to our golden rule, so we're going to recode into a different variable. You'll pick your original variable, then you've got to give the new one a name. We're calling ours age 3, since it'll have 3 categories. Now don't miss this part, it's so important. You have to click that change button. That's what locks in the new name before you can move on.
This next window is where all that planning really pays off. You're basically just going to translate that simple recoding tree we made into instructions that the software can understand. You're telling it, hey, take these old numbers and turn them into these new numbers.
So we just follow our map. For that first group, we'll tell it the old range is 18 through 34, and the new value is 1. Then click Add. And we just do that for every single row on our recoding tree. Once you've got them all in there, you click Continue, then OK, and boom! The software creates your shiny new variable for you.
But hold on, we're not popping the champagne just yet. Step 3 is maybe the most important step of all. We have to check our work. We've got to make absolutely sure that we didn't lose or accidentally create any data along the way. The easiest way to do that? Just check the numbers.
So first, you're going to run a quick frequency check on your original variable. Let's say our sample size here is 1,500 people. That number, 1,500, that's our goal.
Now, we run the exact same check on our brand new variable. And what do we see? 1,500, a perfect match. This simple little check tells us that every single person was successfully recoded. Now we know it's safe to move on to the final step.
So, you have now officially mastered the art of recoding variables safely. But before we wrap up, I'm going to let you in on a pro-level secret that is going to save you so much time in the future. Let's talk about something called syntax.
You know that final OK button we clicked a minute ago to create the variable? Well, what if, instead of clicking OK, you click the button right next to it that says paste? When you do that, the software actually writes out the computer code for the entire recoding process you just built with the menus. This is called pasting to syntax.
So why on earth would you do this? Well, syntax is like a perfect recipe for your data analysis. You can save it, and if you ever need to do the exact same transformation again, you just run the code. No more clicking through all those menus. It's way faster, it's repeatable, and best of all, it creates a perfect logbook of every single change you made to your data. It is an absolute game changer.
And there you have it. You now have the power to take a data set that looks messy and complicated and turn it into something that's clear, meaningful, and ready for analysis. You can find the signal through all the noise. So the only question left is, what hidden stories are waiting inside your data, just waiting for you to find them?